All right, in this video we want to talk about Ohm's law. I would like to start with the geometrical representation, go into the symbolic representation of a resistor, and then draw a circuit, a basic circuit, um, and then talk about Ohm's law. So first of all, if you remember, we have R here, and remember R is the resistivity. It's directly connected to the material, and then we have length. Length is it's the length of this particular conductor or resistive material. And then you have A. A is the cross-sectional area, okay? So if we were to just cut this thing straight in half and then look at it, it would be the cross-sectional area. We also refer to this as the American wire gauge, or people will refer to this as the gauge of the wire. The gauge of the wire can take on stuff. If you were to go and buy it, it's like 18 gauge, 16 gauge, 14 gauge. And the gauges can get higher and they can get lower. But basically, as they get lower, the cross-sectional area gets bigger. So we could just say like this was the cross-sectional area, and then 16 was a little bit bigger, and then 14 is even bigger. So this is the idea behind gauge, okay? So that means that the cross-sectional area is getting bigger, and that's directly connected to this right here. So now let's represent this resistor, or this resistive material, symbolically. And we do that by doing this. This is the symbolic representation of a resistor. And our mathematical representation, again, it is R. Okay? So remember that we can put a battery on this resistor, or this resistive load, and this resistive load can be a light, a computer, a phone. And so what we're going to do is we're going to go ahead and attach a battery. A battery can be made out of acid. You have lead batteries inside of your car. You have alkaline batteries that you put inside your remotes. And so you have batteries like such, and we're going to call this delta V, minus, plus. So by convention, our current goes around like so. So we have I is the current. So Ohm's law can now be presented, and Ohm's law looks like this. It's the battery's voltage equals to the current in the circuit times the resistance of that circuit. So in this particular case, this would be the amount of voltage being produced from this battery is going to equal to I times R here. Okay, so this is going to be Ohm's law. And that's pretty much it. Another way to kind of think about this is to say, and I believe that a more accurate description would be this, that this would be VR. So you have VR and V sub R, and you have I sub R. And that is where V sub R is going to equal to delta V. So delta V in this particular case is actually equal to V sub R. What is that saying? That's saying that the amount of voltage that's being produced by this battery is equal to the amount of voltage that's being consumed by this resistor. Hopefully that's a little bit clearer. And in this particular circuit, I is going to equal to IR. So it's the same all the way through. In a series circuit, I is going to equal to IR. And that's pretty much Ohm's law. Very, very important. And so that was why I was writing that equation the way I was writing. I was writing that delta V equals to I times R. And it's because of this relationship right here. So that's the math. Okay? Hopefully this helps. Oh, it's one more thing that I would like to mention. And that is, I'll mention it in the next video as well, that as this cross-sectional area right here increases, it's going to decrease the resistance. So basically, if this is all the space that electrons have to flow through, it gets bigger as the gauge gets bigger. So basically, as A gets bigger, our resistance will get smaller. And if the length gets longer, okay, it's directly proportional, that means that the resistance is going to get greater. So as the length goes up, the resistance goes up. As the cross-sectional area goes up, the resistance goes down. Okay?